We're going to talk in this part 1 of 2 module on why use cloud. That is a question that's being asked more and more. People have looked at the economics of it, they've looked at the utility of it, and in the future it's going to be probably much more common to hear this stated as why not cloud. And there are some reasons why not cloud, but what I want to examine in detail is why cloud. So there are reasons to not select a cloud solution. It's not the right solution for every problem or every organization. Sometimes an organization has very sensitive data. They have a huge need for privacy and security, and sometimes they'd rather take on the burden of the security themselves. So they don't want to trust any part of it to others. And so they may feel that it's better to have an on-premise solution. The other issue could be cost. Cloud isn't cheap. And particularly when you start looking at a lot of the security or logging or monitoring solutions, or indeed the very high performance database solutions, cloud may be very expensive for an organization. So every organization has to look at whether they can actually afford that. And there's also some times where you want to run software locally. So this is often the case on desktops or laptops. Sometimes, web and mobile solutions, especially when they're not huge, may actually be better to either run locally or in fact run on a small server that you control. So there are reasons why people don't go to the cloud. But there are factors that you have to consider when you look at a cloud solution. And so with these factors, I'm going to explore these in the course. And when we talk about various applications, various uses of the cloud, and when we look at various techniques, these are the factors that you have to consider when you're looking at whether you want to put something in the cloud, or indeed if you decided to put something in the cloud, how you put it in. So cost, scalability, access, configurability, variety, updatability, security, simplicity, dependence, and maintainability are all factors that should be considered for any solution, and they most definitely have to be looked at for cloud solutions. I'm going to go through some of the various uses that people have put the cloud to, and what I'm going to do is, you'll see on the slides at the bottom, I've got some of these factors that these uses and case studies address. So one big application for cloud that a lot of organizations use is for product migration. So this means that an organization has developed a service, and what they may have been running it on premise, or maybe they have just tested it out or developed it on premise, and now what they want to do is they want to put it into the cloud. So this means that you're looking at a production system. So it may be that you have developed all of this, the development part of DevOps is done locally, but when you operationalize it, when you go into production, you want to put it in the cloud for many reasons about scalability, configurability, upgradability, and maintainability. And so usually what people will do is they'll get their service, they'll containerize it, they'll spin up a VM in the cloud, and they'll install and run the container. Scaling the service might, at the very simplest, just include a way to keep repeating that when you need more instances of that service, or in fact putting it in slightly different variations. And so there's many tools out there now for automating containerization and facilitate putting it on various cloud instances or using other cloud services. And so we'll be looking at that in this course. We'll look at containerization, and we'll also look at a system for managing your cloud instances, and we're going to look specifically at Kubernetes. Traffic bursting. This is often a problem, and everybody has run into this. We run into it at the university all the time. So if you go to WebAdvisor or CourseLink, a lot of times there won't be very much traffic. It'll be easy to, you'll get good performance. It'll be easy to access. And other times it'll be terrible because everybody is trying to access it. And you often have this, that there's demand on infrastructure and it spikes over certain periods, either of the day, the week, the year. And so you want to scale up the provisioning of the infrastructure. And the problem is, if you're doing that on premise, if you're doing that yourself, it often means that what you have to do is you have to build for peak. And that means it's going to cost a lot, and that's fine if peak occurs a fair number of times and performance is very, very important. But a lot of times the peaks are only at certain times, and often they're predictable. Or you can measure when a peak is occurring, and so then the alternative to building for that peak and in a way underutilizing your infrastructure is to build for the average or the normal and then accept poor performance at peak. This is often done. It's not a real acceptable solution for a lot of the users. So in the cloud, there are methodologies for handling peak loads where you can spin up more resources when there's demand. You can monitor for that, and then you can release those resources when you don't need it. So this affects cost and scalability. Obviously, when you spin up more resources in the cloud, you're going to pay for it. But when you're not using it, you can not pay for it with a lot of methods. So you can get rid of it. You're not paying for it, so you get your scalability with a cost structure that is manageable and predictable. File storage was the first use of cloud. It's still one of the most popular, and really file storage has gotten out there, so we're very used to being able to access all sorts of different things in the cloud in our file systems. They integrate into our file systems. Often you don't even notice that you're going to Dropbox and that it isn't on your computer. You don't notice those sorts of things, and many services are out there for backing up or replicating your file system or various types of storage. And cloud can be very attractive for file storage because you can, if you want to pay for it, get high availability, high performance, speed, scalability, and security. And we're going to look at that more in the course, but there's a certain level of security that if you use the storage services properly, you get security as you install it. It's that's the norm. And one of the nice things about file storage in the cloud is a lot of the maintenance is already done for you. Some of the you can actually get them to replicate what you're putting in there, and so you have a backup. And so you have workflows for this that are in the cloud that give you this way to address access, security, simplicity, and maintainability. And following on from this, obviously backup. You want to be able to back up everything that is crucial, and you want to be able to get that backup back very quickly. And so you want to automate all of that. You'd like to have a life cycle where everything is automated, and there are those types of workflows that are automated for you in the cloud. And you can also look at with costing, there's ways of taking your backups and putting them on cheaper storage services, archival storage that's cheaper. It may mean that it takes longer to get it back. It's not as high performance. But for some things, this is the actual cost-effective way to do backups. And some of the storage services themselves on the cloud are already backed up in a way they're replicated to ensure that you don't lose data. So at the very least, you can take advantage of the replication that they do in the cloud. So once again, we have security and simplicity on our side when we look at backing up to the cloud. Big advantage of the cloud is disaster recovery. So with the notion of that you can put a lot of your system, you can back it up into the cloud. This means that you can restore from the cloud and that you have a solution for disasters. Now, one of the things that is a big advantage of the cloud is that the major public platforms are very large. They've scaled up to a huge size. And so you have all sorts of data centers around the world. It's unlikely that a disaster will occur at every single location. And so it's very easy to switch from which location you're running in. And so if you're using a data center, let's say in North America, and particularly when you're using, there's some huge disaster, you could switch to using one in Europe. You could get things from backup, you could put them in Europe, you could spin them up there, and then the likelihood of even seeing very much downtime at all is very small. This means that you can transmit things around, particularly with VMs. If the VM can't be spun up on a server farm because there was some sort of disaster and it took out that location, you can quickly move to another geographic location, and there's tools provided to do that kind of thing. So you get the security that comes from knowing that your system won't be down for very long, if at all. The cost is much smaller than if you wanted to replicate this yourself. There's very few organizations that can compete with the amount of infrastructure and the amount of the number of locations that the major cloud platforms have. And it makes this simple. So disaster recovery doesn't become as onerous as it once was. So just as an example of just how distributed one of the public cloud platforms is, this graphic shows the availability zones that AWS has. So we'll be looking at that in more detail when we look at how AWS is set up. But they have 76 availability zones within 24 geographic regions around the world. And so this diagram is from July 2020. They have 205 edge locations, and we'll talk about how edges work. And they have 11 regional edge caches. So this is a very, very large system. Even very large corporations would have a hard time replicating this amount of infrastructure and this spread of infrastructure. So what is an AWS region? It's a physical location where Amazon clusters their data centers. So they have a number of data centers. They're in various regions. Each group of logical data centers is called an availability zone. So you don't necessarily have any idea exactly where you're spinning up an instance or putting your data, but you know what zone it's in, what region it's in. So each of the regions consists of multiple isolated and physically separate availability zones within a geographic area. What this means is that even though the data centers are clustered, they're not dependent on each other in that they can withstand, they're going to withstand various different disasters because they're not going to be connected to each other. So that helps you in attacks. If we look at cyber attacks, it also helps you when we consider physical disasters, geographic disasters. So with their regions, they've spread this risk out. The multiple zones, availability zones, offers many different advantages over what you can necessarily do with your on-premise setup. So each of the zones has independent power, cooling, and physical security. So it means that very few people can actually get into the data centers, and they have independent power and cooling, which means that if the power grid goes down in that geographic region, they have time in which they can stay up independent of that. And they connect everything with redundant ultra low latency networks, so they are able to switch things between. So they can isolate themselves, but they can also connect to be able to then switch over to various parts of their region. So you have the ability, if you want your application to have high availability, you can design it to run in multiple availability zones so that you get a fault tolerance. So you get fault tolerance, and you're going to get probably even different latency depending on where you are for your edge users. So this is something that's very hard to replicate as an individual organization. In an availability zone, you have one or more discrete data centers. They have, once again, redundant power, networking, and connectivity. And all of the availability zones within a region are interconnected. They have high bandwidth, low latency networking that they control in AWS. They have redundant, dedicated microfiber. They have that guarantees them high throughput, low latency networking between these various zones. All of the traffic between the zones is encrypted, and the network performance means that they can accomplish synchronous replication between these zones. So this gives you the ability to design your system to have high availability and low risk for disasters. So if you have an application and you partition it across a zone, it's isolated and protected from things like power outages, lightning strikes, tornadoes, earthquakes, anything that could take out a center. And the zones themselves are physically separated by a meaningful distance. So that means that the likelihood of the same thing happening to multiple zones is small, but they're all within 100 kilometers of each other, so that they can accomplish this low latency networking. Now, one of the applications that a lot of organizations use cloud for are hosted services. It used to be that any organization, any company had to have an IT department so that they could manage the common day-to-day business applications that everybody uses, things like email. And this now is being more and more outsourced to being serviced within the cloud. This means that in a way, you're getting rid of this replication through many organizations doing the same thing. So it means everybody had to have somebody that was taking care of email. Everybody had someone that was taking care of maybe some small database application that everybody had to use, or some particular software that everybody had to use. If you host in the cloud, you can reduce overhead. You can also expand accessibility to all sorts of different services that a small IT department could not host themselves or could not manage themselves. So you're really outsourcing management. And this gives you a lot of advantages with cost, scalability, access, upgradability, security, simplicity, maintainability. What it means is that you're really using the cloud as your IT department or as a part of your IT department. And since most of the public cloud platforms have many dedicated personnel to all sorts of different parts of their services, it means that you have access to experts in all of this. And that is very hard for a small IT department to maintain themselves. Often a small IT department would be dependent on maybe a single person to maintain an application. And if that person leaves or retires or whatever, they have a problem. You don't have this risk if you host your services on a cloud platform. One of the first services that obviously went to cloud was web hosting. The advantage to having it in the cloud is the fact that you can load balance over multiple servers, particularly when you have a web app that is going to have need high availability and is going to have lots of traffic. So you can take advantage of the scaling that you can accomplish and the load balancing that you can accomplish as part of the cloud architecture. You can take advantage of that for your web needs. And so the cloud platforms have services for content delivery, and they almost all of them maintain some notion of domain name services that you can use. Amazon CloudFront is one of the services that is a content delivery network. It makes it easy to get up a distributed network of servers for your to serve out your content. That's what CloudFront is. It has this globally distributed network of proxy servers. They can cache content, so things like if you're streaming videos or any other sort of large media. And this makes it more local to your consumer because they have these distributed all over the world. And so it improves access for downloading your content. And so if you look at this diagram, these are the 216 points of presence that Amazon CloudFront has. It functions in 84 cities across 42 countries. And so it means that they're very close to where your potential users or clients are. And so this helps a lot with the whole problem of latency. And we're going to be looking at performance with latency, with speed, and this is becoming more of an issue, particularly when we get to Internet of Things. So this just is a list of some of the current this is from 2020 of the edge network locations that AWS maintains. They're distributed all over the world, but the one good thing about this too is you may know the city, but you don't know the location. So they maintain a lot of security with this. Microsoft's Azure also has a content delivery network. It does the same sort of thing. You can host your content in Azure or other locations. Azure actually partners with other content providers, or not providers so much as network facilitators, things like the telcos. They don't own the huge network that AWS does. But they have done the same sort of thing with partners. So you can cache static objects from your blob storage, web applications, anything like that, to the closest point of presence server. So it can accelerate your dynamic content by leveraging various networks. If it can't do the dynamic caching, it can look at various networks and routing optimizations that it's done. So if we look at what Microsoft has done about point of presence, here's some of the different ones that they have, and you'll notice that Microsoft maintains some of them, but they also have partnered with Verizon and Akamai, or Akamai, I'm not sure how you pronounce that, but they have various partners that help them in providing these points of presence. What goes along with this is obviously domain name systems for your web service. On Amazon, it's called Route 53. It's fully compliant with IPv6, and Amazon is the AWS also offers domain name registration. You don't get this with all the other services, but through AWS you can purchase and manage your domain names, and Amazon Route 53 will automatically configure the DNS settings for your domains. So you can do everything within the AWS ecosystem. Microsoft Azure has a DNS. It's a hosting service for various domains, provides name resolution using their infrastructure. So you can host your domains in Azure, you can manage your DNS records through them, but you cannot use it to buy a domain name. So you have to go outside of Azure, buy the domain name, and then you can host it within Azure DNS. So in part 2, we'll continue on looking at various applications and the factors that they take into account.